So I like to kind of know our audience before we start these types of discussions. So if I could just see a raise of hands, who brushed their teeth today? All right. Anyone wash their hands? Okay, good. We're all users of water, so you should enjoy this this presentation pretty thoroughly. I'm not going to do a lot of the talking. Paul Trosberg, as Kathy indicated, is our water and sewer operations manager. I assume most of you are Troy residents. We are very fortunate to have Paul in charge of our water and sewer division. I don't think I've ever met anyone as passionate as he is about our water system, and we are in very good hands with all his certifications and his knowledge, and he's going to explain in detail. We should be able to cover all the information in about an hour. There's a lot of information that I think you'll find valuable. The presentation is kind of progressive, so we're going to start very high level and then work our way down to where we're at here in Troy. And we'll be happy to answer any questions at the end of the presentation. So with that, I'll turn it over to Paul.
Good evening. So my name is Paul Trosper, and to give you a little background on me, I've been with the City of Troy. I'm going on my 34th year. I came here, basically I was in the military for 6 years as in the Corps of Engineers, and I was a heavy equipment operator, and I never dreamed that I would one day be here. I always thought I would be running a construction company or something like that. But once I got out, I did that for a while and found out that really wasn't the greatest thing, because you didn't have a summer life, and if it rained, you didn't work. So in 1987, I came to the City of Troy as a laborer in the water department, and right away I knew this was where I wanted to be. And I've been in the water department ever since, and I've moved up from a laborer all the way up to this position now that is actually running the water and sewer division. So, how many of you know where your water comes from? It basically has to go through some pipes that you know, slowly get smaller and smaller. They start up in Lake Huron in a 102-inch diameter pipe, and they keep slowly bringing, and by the time they hit South Boulevard and DeQuinder, they're still in a 96-inch pipe. So any of you that have been over by Beaumont there, right at South Boulevard and DeQuinder, there's that big building that it says DWSD on it, Detroit Water and Sewer, but it's actually owned by Great Lakes Water Authority. So we have our water source, and then Great Lakes Water Authority, who is our provider of water. And give you a little history on Great Lakes Water Authority. In 2014, Oakland, Macomb, Wayne County, and the state of Michigan joined an alliance, it created an alliance to basically lease the water treatment plants, the sewer treatment plants, and all the big transmission lines from the city of Detroit. And they took control of it. In turn, the city of Detroit, who still has actual ownership because they lease this, they actually get $50 million a year. And the stipulation on that $50 million a year is they have to spend it on infrastructure. They can't just spend it on whatever they want in the city. It has to go into their infrastructure. So if you've been in the city of Detroit lately, you see there's a lot of excavations going on and stuff, and they're spending the money, and it's stuff that was long overdue. So here in Troy, this is basically how we get our water. So this is the Great Lakes Water Authority basically system. And all the part in blue is supplied by water from Great Lakes Water Authority. They supply pretty much all of southeast Michigan. And they have 5 water treatment plants, but we only get water from 2 of them. One of them is up here, like I say, at Lake Huron. And a little trivia for you, when you get home tonight, if you get on the computer and look at the internet, punch in 1971, December, Port Huron tunnel explosion. I don't know if any of you ever remember that or heard of that. But if you read the story, you'll understand what happened to get us water, because it involves this. The intake for this plant is 5 miles out into Lake Huron on the bottom. And when it gets to shore, it's 230 foot deep. It's under the lake bed, and then it comes up. So they built a tunnel there to supply this plant. So for us, our water starts right there at that water treatment plant and goes across toward Emily City. There's a pump station there. And then it comes down to, like I was saying, there at DeQuinder and South Boulevard. That's where the last pumping station is before we get it. Now, the other part, and most of the city does get water from that location. Like I say, it's about 85%. But we do get some supplemental water from the Waterworks Park area down in Detroit, down by Belle Isle. And it comes up that way through 8 Mile Road and up to Quinder, basically. So, once it gets to the city of Troy, we have connections in 6 locations and soon to be a 7th. And I'll explain why we're doing a 7th here in a minute. So the sizes that you see there, the 54, the 54, 84, that is the size of the water main that Great Lakes Water Authority has that we are connected to. We have an abundance of water here in the city of Troy. One of the things that we have, very unique, very few communities actually have the big transmission mains on basically 3 of their borders, which really allows us to supply water in different ways in different directions. But there's other things that come into play with that. So when I go back to this, you see that there's these connections. Now, this is a line, this is called the pressure isolation zones. And when these connections bring us water into the city, we can't just let it go wherever it wants to go. And one of the main reasons is, if you notice up here, up at like South Boulevard and Adams, we have an elevation of 860. Where you get down to 14 Mile into Quinder, it's 630. So if you just let water free fall from that north end to the south end, the people on the south end, boy, they'd have fun when they flush their toilet. It would be interesting. You would gain, without even doing anything else, you'd gain about 100 pounds. So these different colors, basically, if you can imagine, these are lines, imaginary lines in the water world. No water crosses those lines. If it's coming in from one connection, let's just say, for instance, right here, that one that says 84, that's at Crooks Road. And if you look at this, you'll see that lighter blue shade there kind of corresponds with that. Water from that 84-inch connection feeds only that area that's lighter blue. Now, say there was a fire over here in this section and it needed some more water. There are some connections interior in certain locations, and they're called a pressure reducing valve. They are set, it's like a pressure regulator. If water was all of a sudden deemed that, wow, we see a big demand over here, they could open and water could cross that line. But it can't cross that line without going through one of these valves. So this is what a pressure reducing valve looks like. So one of the kind of unique things about City of Troy, we don't pump any water. We don't have a single pump, because Great Lakes Water Authority supplies us with enough pressure and we have enough elevation that we actually have to reduce it. So this is what they call a pressure reducing valve. And these things are actually kind of very unique. They were actually designed back in the 1700s. And they require no power, no electricity. They run off of water. And even though the design is obviously, more modern today, actually the true design of it's still the same as it was back in the 1700s. It basically has like a big floating piston in it that you have a top part, and if the water, you want to open the valve, you drain water off the top of this PRV, and it lets that piston float up, lets water through. And then once it says, hey, you've got enough pressure here, it shuts those valves and it pushes that high pressure back into the top and it pushes it back down. It's a super simple system, very reliable, and it can create very consistent pressures that very little fluctuation in them. And that's important, because once you get fluctuations in your system is where you cause a lot of problems with water hammer and water main breaks and things like that. And I'll kind of talk about that a little bit in a minute. So we have our transmission mains and we have our distribution mains. Now this is interior of the city. I already talked about what Great Lakes Water Authority has with their 84s and 54s. So inside the city limits, we have stuff as big as 36-inch and as small as 6-inch. So on the main roads, you're mainly going to find the bigger stuff. And these are kind of like the arteries of our system. These are what supplies the system where it slowly goes down and filters into the businesses and communities, the residential streets. And that's where you're going to find more of the smaller stuff, that is basically our distribution system, which is 12 to 6 inch. On average, most streets have an 8 inch. There are some that have 6, but on average, a residential street, for the most part, has an 8 inch. So this is basically a transmission main would be more like this, where you stand on top of it and you can't move it without a piece of heavy equipment. And a distribution main is something that a couple guys could pick up and put together. So our water system is basically a shared responsibility. And when I say that, I'm not just talking about us and Great Lakes Water Authority. I'm talking about every resident, every business owner. They all share a responsibility in our water system. So this kind of shows you where this kind of responsibility divides. You have your source water, which here in Michigan, we have an abundance of water. We have lakes that the water quality is probably some of the best in the country. I mean, honestly. I couldn't imagine being in a place like Arizona where you don't know if you're going to have enough water to make it through the summer. And, it might be warmer there, but, there's trade-offs. We have water. We're kind of like the Middle East of oil is, we're the water. We have water abundancy. It's unbelievable how much we have if you really start researching it. And so you have the intake comes in and goes into the water treatment plant. And once it leaves there, it goes into the big transmission mains, the 84s and 96s. And it travels throughout the whole southeast Michigan area. And then once it gets to a community, it runs through what they call a master meter. So we get our water metered coming into the city just like we meter the water going into your home, only on a lot larger scale. And that's how we know how much water we have used. And we get billed just like the residents do. We get billed for the water that we have, basically consumed. So once it gets in there, it goes through the pressure reducing valve. And then it goes through our distribution system and ultimately ends up down on Main Street. And it feeds the fire hydrants. And then it goes into the service lines of homes. And this is where the responsibility of the homeowner now begins. Because at the right-of-way of your home, there is what we call a curb stop. And you won't see it. Most of the time it's buried. Some people might know where it's at. It's a little round cap on top. Inside, down about 5 foot, there's a valve. And we got a key we can put in there and turn it on and off if, say, you ever had a pipe break or something like that, or if we had to do some work on the meter. Now, inside the home, the city is responsible for the meter, but that's it. The valves and all the plumbing inside of a home is the homeowner's responsibility. And sometimes you have to really look like, hey, have I updated my faucets lately? Because until 1993, they allowed a lot of lead to be put into like faucets and things. After 93, it was banned. They couldn't use lead solder anymore. And, in the big scope of things, it's such a small amount as long as the water quality is correctly treated, it doesn't really leach out. And I'm not going to go too far into that because Troy doesn't have the lead services of like older communities. We're a young community. We're a very young community compared to, say, a Flint or a Royal Oak, some places like that. Those towns were built back 100 years almost before Troy actually had a water system. And so Troy's water system basically really started to originate in the 60s and early 50s or late 50s. And it was very hit and miss back then. It was wells. The well water was like pure rust. And I've had to open up some old services back in the day that were on the wells right after they had been abandoned, and they were just full of rust. So I couldn't imagine how it was back then, especially up on the north end of town. It was like, it must have been really bad. You would get the lines, they would just be completely full of iron. So they started realizing this in the 60s. And they started talking with the city of Detroit saying, hey, you need to somehow accommodate us and bring us onto your system. And that's where this all started. And after that, it started basically down at DeQuinder, 14 Mile, and it went from there. And then it kind of went up DeQuinder, and then it went across, and then as time went going in the 70s, it really took off, and a lot of this big transmission system was installed in the city. And I give the people credit back then that they had the vision to size things correctly so that most of that stuff is still very capable of handling the demands of today, when in the 70s, Big Beaver was a whole different place. I mean, even when I came here in '87, it was 2-lane road in a lot of places. And I remember doing water taps down there on a 2-lane Big Beaver with the old airport, and nowadays you go stand on Big Beaver and it's a whole nother story. So here in Troy, we are basically what you would call a copper community when it comes to water services. We have services in homes from 3/4 inch, and the 12-inch would be more like a big business or something. Most homes have a 1-inch or a 3/4 inch water service. And Troy has always been a copper community. Even from the inception way back in the 60s, they spec'd copper. And copper has proven itself over the years. It is very durable. You can dig up a piece of copper that was put in the ground, say in 1960, and it still looks like the day it was put in. You know, I really can't say enough about the durability of a copper pipe. But now today, a lot of people are firm believers that plastic is the way to go. And if you were building a home here in Troy today, we'd allow you to put plastic in from the right-of-way to your home, and you could plumb your house with plastic. That's not in our jurisdiction. That's the plumbing code. The state of Michigan allows it, and we accommodate that. But on our side, we still use copper, and we still will in the future. We just believe it's a much more durable and safe product. It's proven itself over years. Plastic hasn't proven itself yet. I mean, I think it's got a pretty good reputation, but still, you hear about it all the time, about plastic leaching into this and that. I'm just not so sure that plastic's the way to go. So this is what a normal street would look like. You would have your water main, you'd have your hydrant, you know, and then you'd have your stop box in your front yard, and it would come into your home. And this goes on and on down every street. So one of the things about a fire hydrant, let me back. That is the only thing that most people ever see of a water system. So you probably never gave it a thought. I give it a thought all the time. If I go to some other community and I look at their hydrants and I'm like, ooh, that looks rough. You know, when you leave here, look at Troy's fire hydrants. That's the only thing you see of the system. Everything else is buried. You can't see it. You don't know if it's good, you don't know if it's bad. All you know is it's there. And you know, if the road's got potholes, you know it. But if a water main's bad, you don't know. Same with a sanitary sewer or a storm drain. You know, you don't see it. But look at the fire hydrants. That's all I'm gonna leave it at that.
Interesting fact. The fire hydrant was actually at one time called a fire plug, and that's because when they went to the water main for the source of water to put out fires, they would actually drill a hole in the water main to get the water to put out the fire, and then they would plug that hole after they were done, and it wouldn't be reused before. So one of the old taglines of a fire hydrant are actually called fire plugs, and that's the reason why.
So who oversees all this? Who makes the regulations? Who tells you, hey, this is what you have to do to make sure you're safe? Well, here in Michigan, we have the state, and we have some EPA federal standards. And basically here in the state, the EPA allows, formerly it was called the Department of Environmental Quality, now it's called the Department of Energy, Environment, Great Lakes, and Energy. I like DEQ better, but that's my preference. So anyway, we have certain criteria, certain testing, and regulations that we have to follow that basically come from the federal level and filter down through the state, and then ultimately we are obliged to comply with. So at Great Lakes Water Authority, they have their own lab inside their treatment plant, And just so you know, any of you would ever want to go see the water treatment plant, you can go on Great Lake Water Authority's website, and they are more than happy, as long as there's 5 of you, to schedule a tour. Doesn't cost you a dime, and they will walk you through the whole water treatment plant down in Detroit at Great Lakes at Waterworks Park. It's a great tour. I would highly encourage anyone, after talking about water, to go check this out. So they have their own lab, and they test on a daily basis for all the water that's coming into the plant. They test the pH of the water, and the pH is very important. It's one of the most important things as far as keeping the stability of your system from corrosion and things like that. Now the bacteria, obviously they don't want bacteria in the system, and there's always bacteria in everything we touch, but they check for the bacteria that is harmful to humans. And then they test the minerals, and they test the minerals every day, and it brings it in. And I'll show you here in a second what they do test. PFAS, now that's a whole new thing that's just come around. People didn't even think about that a couple years ago, and all of a sudden, boy, has that come up. And PFAS is something that's really found mostly in groundwater. Now, I'm not to say that it can't be in surface water, because they have had some spots that have had it. But it's mainly something that is leached into the ground and got into an aquifer, and it's usually around a factory or something. Firefighting foam was very much part of that. And they found it in places that had like Air Force bases, things like that. There was really heavily found there. So it's a new contaminant that, truthfully, it's still what they consider an unregulated contaminant. Some things are regulated, some things aren't. But this is one that I think you're going to see in the next couple of years. It's going to become what they call a regulated one, and it's going to be tested on a regular basis. They're already testing for it, all the time. But it's not like they don't have to report the findings that much, even though they have been, because people are asking about it. And they have found it in mostly the groundwater sources. Now, Great Lakes Water Authority has been testing for it since 2009 and have not had a single hit on their intakes out of the Great Lakes. Here in the city of Troy, we do some testing of our own. We do the lead and copper testing, and we also do a lot of bacterial testing. On average, we use Oakland County's lab for our bacterial sampling. I would have to say we probably send 500 to 700 samples a year over there to get tested. And some of that's with new construction, because we test everything before it gets put into the system. We test the schools, it's a vast variety of places that we end up testing for bacteria. But Great Lakes Water Authority also tests within the city of Troy on a daily basis also. They're required by law to test 80 locations in Troy on a monthly basis. Now, some of these, it's kind of the locations have to be public areas or places that a person can come and get inside, and there's certain criteria of where they can test. They have to have a faucet that has 2 handles. They can't have the single control handle because they don't want to test the hot water side. They want to test the cold water side. So we had to come up with, at minimum, 30 locations that were public places spread out across the city that they could come to on a daily basis and grab a sample. And these people that are doing these samples, they're kind of like, they can't be wasting time. They have to get so many in a day and get them back to the lab. So we had to make them convenient. So we have done some stuff where we put them on the outside of the fire hall so they don't even have to go inside. We have a special test spigot on the outside that they can open up a locked box, get a sample, and there's 6 fire stations. And we do some at some of the local businesses that are open to the public. Here at City Hall, we do them. At the community center, we do it. So we do it all over the city. So, how many of you have ever read our Troy annual water report that comes out in the summer, Troy Today? I'm glad to see that, yeah. And it's kind of redundant. It really doesn't, unless something changes, the numbers are going to stay the same. We tell you what's required of us, and we tell you what the minerals and the levels of lead. And so, while I'm touching on that, we just did our lead testing this year. And It came back, the highest level we had was 1 part per trillion at one home. And it was not in our system, it was in the home's plumbing. Because lead testing is a little unique. We don't do it ourselves. We have to get volunteers to do it inside their home. And it has to be done first thing in the morning before they use any water. So we have to kind of educate these places. We're doing 30 of them a year right now. And we use mostly the older homes. We try to find places that we can, because we have to get them these bottles. We have to get them back from them. We have to make sure they do it correctly. And then we get all the results and we compile them. We send the people that did the testing their personal results. And then we compile the rest of them and put them in our annual report and send them also to the state for their reports. And the action level is 15 parts per trillion. Okay? Now, here in Troy, like I say, we had one hit that was 1.1, I think. Most of them were non-detectable. Of the 30, I think 20 of them were non-detectable. There was one that was 1.4, and then the next one down was like 0.9. And we follow a guideline where they call it the 90th percentile. So when you get the Troy annual report this year, you're going to see that the lead level is recorded as 1 part per trillion. And the reason is they round up, which if you had a community that had 15 or 14 parts per trillion and you round it up to 15, now you're in a level where you have to do a whole lot of reporting to where, so I'm not agreeing with the fact that they round up. I think I would prefer to see it showing the truth that our 90th percentile is actually 0.8. It's not 1. But that's the way the DEQ or the Eagle wants to do it, then I have to comply. So these are the minerals that Great Lakes Water Authority tests for every day. And they test for turbidity, and that's more the cloudiness of the water. And you know, the solids, they test the solids, and then they test for aluminum and iron and copper and magnesium, and they go down. And this is a daily thing. This is one of their reports that I grabbed just to show you that this is a daily report that they do. And you see the pH, and it comes in, it shows you what it comes in at as the raw water intake, and then it shows you what it is after treatment. So our water here is actually what they call a medium hardness. And anyone that's using a water softener here, it's not necessary. It really isn't. But some people like it really soft water, but the hardness of the water here really doesn't require a treatment. So pH. Any of you have a pool? If you have a pool, you know that pH is important. You always have to worry about the pH of your pool. So as you went back to this, you'll see that on average, our pH here in Troy, and I tested at our shop usually a couple times a week, and it usually comes in right around that same number, 7.4. So on the pH scale, as you can see, 7 is pure water. You get into the other ones, you start going toward the 0, well, that's a battery acid. You go to the other end there, it's more like drain cleaner. But surprisingly, when you look at this, is you look at like a lemon. A lemon is very acidic. But this is what really helps keep the water from causing problems in your system. You've got to keep a good pH level because it's more neutral. Now they do add some chemicals that basically protect the linings of the pipes. And as long as those chemicals are there, you can have lead services and they're not really going to be a problem. They're not going to leach. As long as you have your pH right. But if that pH goes out of whack and those chemicals aren't in place, it starts to corrode and eat at the linings of the pipes. And that's where things could really go bad. So how does the state know the people that are doing it in each community know what they're doing? Well, they have a certification program. And it starts at a low level. You can get an entry-level license. And S1 is the highest level you can get in waterworks systems. Now, the D4 is a limited treatment. Now here in Troy, we don't do really any treatment. The only treatment we do is new construction. We chlorinate and pressure test and things like that on all new pipes. So a D4 is required for that type of work. But the S1, each community is required to have at least one S1 on their staff and one backup. Now the backup can be, and it goes from S1 to S5. They have to have at least one backup that has to be an S3 at minimum. They prefer another S1. And you are called the operator in charge. And if you do not have this, then you are not allowed to be basically in charge of a water system. Somebody has to have this certification in every community. And it depends. If you had a small village community of, say, maybe 1,000 people, an S1 isn't required. You can get away with an S3. There's certain levels. But in the city of size of Troy, with our population and number of services, an S1 is absolutely required. So,
what's our backup and how many of our employees
so
have
we actually have S1s, we actually have 3 on staff. And we also have about 10 other certified operators on our staff. It's kind of amazing to me that the state of Michigan doesn't require everyone that works in water to have this. They don't. I've fought for this for a while. I've been arguing this point. So we really push our employees to get it. And once you get it, you have to go to class and get so many credits of education to renew it every 3 years. So we really promote this to our employees, and we send them, once they get their license, we send them to classes and seminars so that they have enough of their credit, continuing credits to renew every 3 years. And it just makes it, to me, it's a source of pride, but it also shows our community that these operators are certified. They know what they're doing. And to me, that's important. So another thing with water systems that a lot of people don't even think about is backflow protection. Now, backflow protection comes in a lot of different categories. And some of you probably in the last few years have gotten a letter and asked you if you had an irrigation system and you had to test it. Never did before. Well, the rules changed. Before it was always commercial, and the state started realizing, we really should start looking at other things, because they looked at case studies and they found that it's not like it's real likely that you could have a problem with water backflowing into your system from an irrigation system, but it has happened. And basically, say it's a 1 in 10,000. Do you want to be that one? You don't. Because what this basically does is it protects the potable water system from water that now could be considered non-potable. It could be contaminated with, say, in an irrigation system with fertilizers, or, if you have a dog, it could be a dog's droppings or anything out in your lawn. And this here only allows water to go one way. So once it's into your irrigation system, water cannot backfeed into your home, no matter what happens. It'll go to this point. If it notices that it's trying to reverse flow, it'll pop a valve and it'll just bleed it off. And there have been case studies where people have done like pesticides and sprayed their yard. And not here in Michigan. This one here was in Pennsylvania that I was just reading about. And this gentleman, he had sprayed his yard. He was having a problem with some kind of insect. And he sprayed his yard with some very toxic pesticide. And it just so happened right after that happened, there was a fire on his street. And the fire drew so much water out of the main water system that it basically created a siphon, and it was drawing water actually from his home. Well, he didn't have one of these backflow preventers on his system, and some of this pesticide basically got sucked right back into his system. It didn't leave his house, it just stayed in his home. But then after he was done outside doing all this, he seen the fire and he went in and he had a couple glasses of water and he started feeling really sick. And it truly killed him. And if you go and look at case studies, you can find hundreds of them like this. And like I say, might be a very minimal chance it happens, but do you want to be that one chance? And that's why we require you to now test your irrigation system's backflow. We are trying to protect our system of all risks that we can possibly prevent. Now, some of the bigger stuff is in like a fire system. And it's the basically same technology. And this is basically just telling you that, hey, once it's in your fire system, that water may sit in a fire system for years. If you don't have a fire, it'll just sit there. And once it's sitting there and it gets all stagnant, you don't want that back into your drinking water. So that's what these backflow preventers on a fire suppression system or on a boiler. If you have a water-powered backup sump pump, they're required to have one. Things like that. It's important to have. And this is basically some of the things that backflow preventers prevent. In medical system, medical is really bad. You don't know what you're getting in a medical facility. So some medical facilities could have 10, 20, 30 of these things. They might be small, but they're on every fixture. And we actually have a gentleman, that's his whole job, is to keep an eye and keep track of all these backflow preventers. So, what impacts our use of water? Well, the number one impact, hands down, is our weather. If it's hot and dry, we use a lot of water. A lot of water. But if we have cold, rainy like we have been, it drops dramatically. And not only that, but all the new household fixtures are a lot more efficient. That back in the day, you'd have a toilet that would hold 3-4 gallons of water. Nowadays, a gallon and a half. And same thing goes with your wash machines. These front loaders don't use nearly the water the old big Westinghouses used to use. And the time of day. 2 times a day, every day, doesn't matter if it's summer or winter, we use more water between 4 a.m. and 6 a.m. and 6 p.m. and 8 p.m. every day. And that's when people are leaving for work and when they're coming home. And in that first early morning in the summertime, that's why we have a irrigation watering ordinance. Because our contract with Great Lakes Water Authority, they try to size their treatment plants to fit the system. So as a customer, we tell Great Lakes Water Authority, on our most peak day, we need for at least 1 hour, we need a peak of 40 million gallons a day. And for that full day, our peak, we need to have a supply that can at least handle 27 million gallons a day. And that's our contract. So we have to abide by those contract rules. So here is a reasoning why. So you can see this. This is yearly pumping, okay? And these are 2 different years that we're showing. One, the dark one, is 2012. This is 2017. So back in 2012, Great Lakes Water Authority, and this is not just the Troy here, this is for the whole Great Lakes Water Authority system. This is looking August here. They were pumping on a couple of days in excess of about 940 million gallons a day. 2012, last time they ever hit that. Since then, it's been declining. So now, here in 2017, we had a peak. They had a peak of about 620. And that's about where the new high is anymore. And it all comes back to ordinances and the new facilities that you can buy, the new faucets, wash machines, things like that. People aren't using as much water. And it's kind of a weird thing. I'm in a business where I want to sell you water, but I also have to tell you to conserve it. It's kind of a double-edged sword. But that's the way it is. And so when they start seeing that these levels went down, they can now kind of scale back their system and not treat, they can kind of like cut down some pumps. They can cut down, they're actually thinking of basically decommissioning one of their water treatment plants because they're not using that much water anymore. And they don't see in the foreseeable future any time that they'll ever hit this 900 million gallons a day again. So here in Troy, on a July hot summer day, as you can see, 4 a.m. to 5 a.m., here we are, boy, we're pumping the water. If you go into one of our intakes, it sounds like a freight train. That's how much water is coming into our system. And then you can see right about 8 o'clock, it starts to dropping off. And by noon, we're down to right around 15 million gallon flow a day. This is hourly rates. This isn't for a full day. And then about 6 o'clock, it starts climbing again. And if you looked at a week, it would look just like this, back and forth, back and forth, back and forth. It's pretty consistent. So, here we are in Troy. Our operation doesn't stop just because it's raining, snowing. Matter of fact, the colder it is, the worse the weather is, the more issues we have, the harder we end up working. Water does not like cold weather. It's just somehow it gets really frozen. And when it breaks, it usually breaks at this time of year, and then you get something that looks like this running down the street or in your backyard or wherever the low point is. And we get out there, we don't let it run. We get out there and we fix it then and now. We don't want it to sit there. And we've got people on call 24 hours a day. If they got a call right now, we would get it all marked through Mistig and we'd be out there tonight. We'd fix it. We don't wait till tomorrow.
Well, how many breaks a year do we typically have?
So right now we're averaging about 20 water main breaks a year, which I can tell you, and I'm not going to name any other communities, but some of the other communities in the area, they get that many in a week. So,
How do you keep the pipes from freezing?
well, they're all buried in the ground. Average depth of a water main here in Troy is 5 foot. Some of them are a lot deeper, but on average they're about 5 foot deep. So they're below the frost line. And truthfully, the water mains, when they break in the winter, some people will tell you it's frost that does it. I don't believe that. I believe it's the temperature of the water. Because you've got the ground, it stays pretty consistent, about 6 foot deep, about 53 degrees. That ground's going to be 53 degrees. I don't care if it's middle of February or middle of August. But you're pumping water out of Lake Huron, and that water's about 32, and now you're pumping all this cold water into a system that's 53 degrees. And it's all summer it's had nice, not really warm water, because I don't think it ever gets much more above 50, but you're getting this shock of cold water, and I think that does contribute to it. Frost does play into it though, but lately we haven't had a lot of frost. So here in Troy, we've got 6,500 fire hydrants. And I have just about as many valves. We've got about 548 miles of water main growing every day. If you just look around, you see construction. It's every place that you see construction, there's new water main, new sewer. And we got about 28,000 water meters. So one of the things that's unique about Troy here with water meters is our water meter crew, actually, we do a water meter replacement program. Because we found that after about 10 or 12 years, a meter starts to become inaccurate. And when I say it's inaccurate, it's to our loss, not yours. A meter usually loses accuracy and becomes less accurate. It doesn't read high, it just starts to read less, especially at low flows. So some of you may have already had a letter or asked to do a meter exchange in your home, and we may have been there. But we try to get in every 10 years or 12 years and try to get in and change our meters. So if we were going to put new meters in every home, it could be pretty costly. So about 12 years ago, one of our staff members said, why don't we rebuild them? So we started looking into it. And sure enough, a meter of that size, like a residential meter, if you bought it brand new, it's about $130, somewhere in there. You can rebuild it for about 20. Put all new parts, just like the body's brass. It doesn't wear out. So you take it apart, you clean it all up, you put all new internals in it, You put it back together, it's like a brand new meter for $20. And and we test every one of them before it goes back in the system to make sure it's accurate. And here we go with the fire hydrants. Fire hydrants, like I said, are the only thing you ever see of the system. And most people envision when you hit a fire hydrant, water's going to shoot in the air, like the Hollywood movies. And in Hollywood or in California, that's probably would happen. But here in Michigan, we have a different type of fire hydrant than they do out west or any place that's warm. We have what they call a dry barrel fire hydrant. So basically, this is ground level. The water actually, the valve for that hydrant is down here at about 5 foot, 6 foot deep. So there's actually no water in this section of the fire hydrant until it's needed. Now, this comes with another dilemma, though, that we have to deal with every year in the fall. And it's not really a dilemma, it's actually a good thing, because what we do every fall, we go to every 6,000 fire hydrants, we turn them on, make sure they work, we pressure test them, make sure they're not leaking below ground, we document if there's any damage or anything to them, and then we have to pump every one of them dry. Because back in the day when these dry barrel hydrants were originally designed, they had a little weep hole right here. But about 25 years ago, the EPA said, well, wait a minute. That's a cross connection. That's a backflow problem. You need to cap that hole. So now the only way to get the water out of them is use a pump. So all 6,000 of them, they get checked. We verify they work. And I can tell you right now, I think we have 3 fire hydrants out of 6,000 that aren't working. And they're on a list to get repaired, or they're in a situation where the building service line is out of service for some reason, and it happens to be on that line and we can't turn it on because the building has construction going on or something. Our fire department knows that when they go to one of our fire hydrants, it's going to work. And it's going to work in a way that we have insurance companies come to town. They do these things called flow tests. And they can't believe our numbers sometimes, because they do this test where they take 2 gauges and they put it on one fire hydrant, and they call that the static pressure, and then they put it on the one down, like say they're going to build a new building, and they flow the fire hydrant there. So in theory, once you start flowing that, you should see at the one that's static, you should see a pressure drop. And they record this pressure drop, and that gives them their numbers for their flow tests. But because we have so many connections to the Great Lakes Water Authority, we have so much pressure built behind these connections, that if you turn on a fire hydrant here in Troy, and you're doing a flow test like that, for about 2 seconds you'll see it drop, and then all of a sudden it goes up. And it climbs 10 pounds more than it was static. And they're like, something's wrong. There's something wrong here. And it's like, no, this is our system. Because our average fire hydrant, we can flow about 2,500, some of them as much as 3,000 gallons a minute out of them. It's a lot of water.
Well, what does the different color caps mean?
So, yep, if you notice that all the different hydrants in the city have a different color cap. And those are mainly for fire department use. And they designate the size of the water main that the particular hydrant that they're in front of is connected to. Say, for instance, a red cap means 6-inch, orange cap, 8-inch, a green cap is 12-inch, a blue cap is bigger than 12. And they know just how much, because one of these new modern fire trucks, they can draw some serious water. And in our system, it's not so much of a concern, but if you were in a system that didn't have quite the volume that you had behind it, you could actually suck a water main dry and then cause a cross connection, because now you've sucked water out of it like a straw and brought everything in from the outside like in a vacuum. So this is what it mainly would look like when you go down the road. When you go down the road, this is what you basically see. You've got the water main, you've got the T for the hydrant, you've got a valve, and this valve here, they call that the companion valve, and every hydrant has one. There's a little box to access it somewhere in front of it or on the side of it. And that's mainly just there to do maintenance on that fire hydrant, maintenance repair. So you can turn that off, isolate that hydrant from the system, tear it apart if you had to. So, ultimately, just like anything else that we have that's made, things happen, and you have leaks. Some of our leaks, fairly small, they may not even surface for a while, and then, but most of the time they always surface. We have had a few that somehow we found that never surface, but generally speaking, they find their way to the surface, one way or another. Some of them are a lot larger. Some of them are just from frost or cold weather. Some of them are from age. Some of them are from damage that a contractor did. That happens to be this one. A contractor was digging, didn't see this 16-inch water main, and he punctured a big hole in the side of it. Now this water main here is made out of concrete with steel liner, and it's pre-stressed. So this type of pipe is kind of unique. It can handle huge pressures, and it's very, very durable. I mean, it's got a 100-year lifespan. But if it gets damaged, you can't just put a Band-Aid on it. You have to pull out a whole section. So you have to pull 20 foot of this whole pipe out and replace the whole 20 foot from joint to joint. And that's what we're doing there, is we're cutting a section out so that we can pull the two ends apart. Some of them are even bigger. This was actually in Troy right here. That's a water main. As you can see, the guy standing on top of it, and that's a piece of pipe that they're about to put in there. Back in 2016, just around Thanksgiving, I got a call at 4 o'clock in the morning. My guy is on call, says, we're losing pressure. I'm like, what do you mean you're losing pressure? Where? He goes, everywhere. I'm like, how are we losing it everywhere? He goes, I don't know. Because I'm on my way in. He goes, I don't know if it's something going on with our telemetry or something. He goes, but we're losing pressure. So I said, I'll head in. So I get in my car and start coming in, and he calls me and goes, Great Lakes Water Authority just called me. They said they have a problem. And it's over on South Boulevard. They don't know what it is or where it is, but it's on South Boulevard. So my man that was on call, Mark, he says, I'm going to go to the yard, start getting some people in here. We got to start stopping the bleed. And I said, well, I'm going to go over there and see what's going on. So I get over on South Boulevard by Flynn Park, and the police already had the road blocked. And he stops me, and I was in my personal vehicle. He didn't know who I was. And I said, hey, I'm going to go down and see what's going on. He goes, I wouldn't go down there. The road's flooded, and I don't know where it ends or what's going on. I said, come on with me. I know the area. I know what's down there. So we went down there, and this 84-inch water main had broke. And it was pumping probably about 1 million gallons an hour or so onto the road. It was picking up pieces of sidewalk. It was picking up pieces of dirt and throwing them out of the hole onto South Boulevard. And they had the road blocked, and it was just like a giant lake. And in all of this, all of a sudden a Ford Focus comes off of M59, goes right around all the police cars, and starts heading toward this flood in the water. And I have a big floodlight, and I'm trying to stop it, and there's a police officer with me, and we're both trying to stop this. And it was an older lady, and it looked like her husband in the passenger seat. She would not look at me. She wouldn't even turn her eyes. She just kept driving. And I'm like, oh no. And that officer says, we're going to have a rescue, aren't we? I said, I think we are. And she drove through. She was in a Ford Focus. You've got to remember that. Water that was this high. Once she got in the water, she turned her wipers on. And she drove for about 200 yards through water that deep, out the other side, and kept going. And we both looked at each other like, and that officer, I can't remember which officer's name it was, he goes, I think I might buy one of those. And once the water got turned off, how they made it, I don't know, because there was pieces of concrete, there was pieces of dirt. I don't know how they made it through there. Somebody was watching over them, that's all I can say. So, here in each house, we have a meter, and it looks similar to that. And this is how we know how much water you've used and how we bill you. And we bill by the cubic foot. And that right back there, in case you didn't see it when you come in, is a cubic foot of water. So, when we bill, we read these kind of like an odometer on a car.
Boy, are you strong.
And we get a read remotely. On the side of your home, there's a little gray box, and our one truck drives down the road, and it can gather the whole neighborhood's reads in a matter of a couple minutes. And there's also on top, there's this little triangle, and they call that the leak detector. So say you had a high bill and you're like, oh, I didn't use that much water. Where's it going? First thing I tell somebody is to go down to their meter, turn off every faucet, make sure there's nothing going on. Go down and see if that little triangle's turning. Because if it's turning, there's water going somewhere. And a lot of times it'll be a humidifier on a furnace. It could be a water-powered sump pump. It could be an irrigation system in the summertime that has a bad control valve. It's a numerous things. Toilets are notorious. It's unbelievable how much water a leaky toilet can use. If you look at those little, I've got some little rulers back there, and it has some little indicators on it show you just how much water you lose out of a small leak. But a small leaky toilet can use about 74,000 gallons in a month. It's kind of crazy, but it's true. So this kind of shows you right here. If you had, one drop of water dripping every second out of a faucet, in a day, you're going to lose about 4.5 gallons. You can live with that. But when you really look at the big picture, if it leaked for a whole year, you're losing 1,600 gallons of water. But look what happens when you start getting into big stuff. Say you had an irrigation system that had just a pinhole leak in the control system and it wasn't turning off. Boy, every day you're losing about 822 gallons of water. Or, in a year, 300,000. I see this a lot. I see this surprisingly a lot. And if you have a water-powered sump pump in your home, get familiar with what it sounds like. Because when they turn on, most of the time they don't turn off. And they will pump every 2 gallons of water that they use out of our system to pump 1 gallon. And they discharge it back into that sump. So it's a continuous problem. And they will pump for days. And they'll call and they'll say, I don't have a leak. And I'll send a service tech over there. And as soon as he walks in the house, he goes, you hear that? I don't hear nothing. You go downstairs and this thing's been running for a month. At more like that or this. As you can see, your water bill get pretty high. So this is how most people use their water, and this is where it goes. Most of this can't really be changed. It's just a fact of life, except for this part. If you make sure you're leak-free, you can kind of reduce your water. And I'd say for the most part, most people, if they see something leaking, they fix it. But some things you don't notice. Like I said, a humidifier on a furnace, you wouldn't even notice it really. It just kind of drips down into a sump pump or a drain and just continues going. So here in Troy, our water is measured in cubic feet. And like Kathy just showed you, that's 1 cubic foot. So we do 1 unit of water. When your water bill comes, it'll tell you how many units of water you used. So a unit of water is 100 of those cubes, 100 cubic feet, or 748 gallons. How many of you bought a bottle of water recently? Come on, I know more of you have. Yeah. Why do you buy water in a bottle? Is it safe? Is that why? Convenient. You know, water in a bottle isn't regulated by the EPA, federal guidelines. It's regulated by the Food and Drug Administration. It has a whole different set of category. They can tell you whatever they want on a bottle of water. They really can. They can tell you it's spring water and they can get it from Detroit.
Like Nestle.
You know? Yeah. So anyway, that 748 gallons that I'll sell you for a unit of water cost you $6.87. And that also includes the wastewater disposal charge. Now, how many of these can you fill with that 748 gallons? About 5,665. So in the scheme of things, water is actually still probably the best deal out there. We go to great strides to make sure that what you're getting in your home is safe, dependable, because the last thing you want to do is come home, turn on your faucet, and you have rusty water or no water at all. And it's a big job. We spend hours and days to make sure that it all comes together.
This is the last slide before the
Yep.
questions. So we've got a quick little wrap-up video, and then we'll open it up to questions. It's just a real quick overview, that high-level highlight that.
I found this video and I thought it was really good about explaining the whole system about paying for water.
You probably don't give it much thought, but fresh water crosses your mind several times a day. From the moment you first turn on the faucet to that time when the water bill arrives. Considering that a family of 4 uses an average of this much water a day, it's amazing how little people know about where their water comes from, how it gets to you, or why it costs what it does. So here, with the help of our own water meter, is the least you should know about that water that you not only love, but need to survive. First, everyone's water comes from nature, from snow melting in the mountains to rivers, lakes, and underground aquifers. Getting this water to where you are can take hundreds of miles of pipe, thousands of watts of electricity, and hundreds of hours of manpower. This is the part of water that you pay for. Your water provider first pumps water from the source through underground pipes to a water treatment facility, which processes millions of gallons of water a day. Here, it's cleaned, filtered, disinfected, and tested constantly by professionals until it's safe for you to drink. This, your future tap water, is then pumped into a pipe distribution system, sending water to homes and businesses through miles of pipe deep underground. Many of those pipes were installed decades ago and must be repaired or replaced. And that's how water arrives where you need it: to shower, wash your dog, cook a meal, water your lawn, put out fires, and make lemonade. Oh, about that water bill? Each month, utility professionals read your meter to track your water use, just doing their job. Water, so vital to life, still costs less than most services we use today. Even after you've used it, your water doesn't disappear. It's collected and cleaned by your local treatment plant until it's safe to return to waterways and be reused by the community or your neighbors downstream. Providing clean water keeps communities healthy. But managing our precious supply while keeping costs down doesn't just happen. Every step in the fresh water cycle is a big job for our nation's utilities, and that's where you can help. By sharing the cost and conserving water for future generations, we can all help to keep fresh water available and affordable today and for years to come. The pleasures and the cost of fresh water belong to all of us. Paying your water bill is an investment in our water future. So here's to safe drinking water, and the pipes, the plants, the power, and the people who make it happen. That is water's true value. To learn more about your own water bill, contact your local water supplier.
So one of the things that Great Lakes Water Authority is really trying to push is what they call their one water concept. And they want people to understand that it's ultimately one water. The water that today is coming out of the sky as rain, going into the storm drain, or the water you flushed down your toilet today, ultimately is the same water that you're drinking. It's all one water. It's recycled over and over and over again. It's probably the greatest vessel to transport things in this world. It is. It can be cleaned again and again and again. That's why we have to really put things in it that can't be cleaned. And there are very few things they can't get out of water. There are some. They're finding that some medicines and things stay in there for a very long time. People dumping medicine down the toilet to get rid of it, it's expired. Don't do that, because ultimately the wastewater treatment plant can't treat it, can't get it out. It ends up in the fish, it ends up in the lakes, things like that. And they're really trying to push that concept that it's everyone's responsibility right from your yard and making sure you don't let things get down, the storm drain in front of your home, the oils and fertilizers, things like that, to taking care of everything in your home. And It's so true. It's every one of us' responsibility for this water that we are so abundant with here in Michigan. We have so fortunate compared to some other areas. And we have an obligation to make sure that it's taken care of. And for many decades, I hate to say it, but this area wasn't that kind to our waterways and everything. Industry kind of really used it as to their advantage. And people realize that now. And I think you can see it just from the wildlife that you see now and things like that. The lakes and the rivers and everything are far cleaner than they were, say, even 50 years ago. And, but there's other things now coming up, this PFAS, things like that people never knew before. So it's always evolving. And I can tell you that we spend most of our day either making sure that people have water because of whatever reason or not, testing the water, or maintaining the system. That's our day. When you have this much of a system, you've got miles of pipe, you've got hydrants and valves, and you've got, 28,000 customers. It's never boring. And we spend a lot, that's what we do. And I'm pretty proud of what we have here in Troy. I'd put it up against any city.